Okay, welcome to I Square Maths Academy, where numbers and variables actually meet mastery. Today we are going to be looking at arithmetic progression, commonly referred to as AP. Yes, AP. Now, first of all, what is arithmetic progression? Now, an arithmetic progression An arithmetic progression is, is a linear sequence. Is a linear sequence with a constant, common difference. Yes, with a constant common difference, D. Full stop. Yes. An arithmetic progression is a linear sequence with a constant common difference. Now, when we say common difference, now D, if you have a sequence, let's say for example, you have 2, 4, 6, 9. Now, let's look at this. Let's see if the common difference is constant. Yes. Now, the common difference is the second term minus the first term, or the third term minus the second term, or the fourth term continuously like that. So let's look at this. This is the first term, this is the second term. So here we have 4 minus 2. Yes, 4 minus 2 is 2. Yes. Let's look at the next one. 6 minus 2. 6 minus 4 rather. Now 6 minus 4 is 2. Now let's look at the next one. 9 minus 6. 9 minus 6 is 3. So it therefore means that this is not a linear sequence. Yes, for this sequence to be called a linear sequence, the common difference must be constant. Yes, the common difference must be constant. So here we have seen this, that the common difference is not constant, so you cannot call this a linear sequence or arithmetic progression. Now let's look at the nth term of an AP. The nth term of an AP, the nth term of an AP is given by UN is equal to A plus N minus 1 times D. Yes. Where A is the first term. Yes, A is the first term. Yes, A is the first term. N is the number of terms. The number of terms. Yes. And D is the common difference. D is the common difference. So this is the formula for finding or calculating the nth term of an AP or of a linear sequence. Now, let's read it again. UN is equal to A plus N minus 1 times D. And we said A is the first term, D is the common difference, and N is the number of terms. Now, let's look at the sum of the first n terms of a linear sequence. Now, the sum of the first n terms of an AP, yes, an AP, that is arithmetic progression, or linear sequence, AP or linear sequence, is given by Sn. Yes, that's the sum of the first n terms. It's given by n all over 2a plus n minus 1 times the value of d. Yes. Now remember from the definition of terms, We said A is the first term, N is the number of terms, and D is the common difference. D is the common difference. Now, this is the formula. This is the formula for calculating or finding the sum of the first n terms of a linear sequence. Now, there's another formula that we can also use to calculate for the sum of the first n terms of an AP. Now, let's look at the formula. We have Sn is equal to n all over 2 in bracket A plus L, where L is the last term. Yes, L is the last term. Yes, L is the last term. When we say L is the last term, just like, for example, if you are looking for or you want to find the sum of the first 10 terms of a linear sequence, it means the last term would be the 10th term. If you are finding the sum of the first 20 terms of an AP or a linear sequence, the last term will be the 20th term. So that is what we actually put here as what? L, the last term. Now let's look at example 1. Yes, let's look at example 1. Now, given the following linear sequence, yes, so here we have 5, we have 7, 9, 11 continuously. Now the question is, find the following. Yes, A, we have 7th term. Yes, 7th term. The 7th term. B, 10th term. Yes. Then C, we have the 12th term. The 12th term. D, the sum of the first 10 terms. Yes. E, the sum of the first 50 terms. Yes, 50 terms. Now, this is a question. Now, given the following linear sequence, that is arithmetic progression, AP, we have 5, 7, 9, 11 continuously. Now we're asked to find the following: A, the 7th term, B, the 10th term, C, the 12th term, D, the sum of the first 10 terms, E, the sum of the first 50 terms. Now, solution. Now, remember we said the nth term of an AP. Yes, the nth term of an AP is given by, we have A plus n minus 1 times D. Yes, A plus n minus 1 times D. So it means at this point, our A will be equal to, now remember from the definition of terms. Yes, we said A is the first term. Yes, we said A is the first term. A is the first term. So our A in this case is equal to 5. A is 5. Now let's look at D. D is the common difference. Yes, when we say common difference, I said it's either you use the second minus the first, the third minus the second, the fourth minus the third, and so on and so forth. So now let's look at D now. Second minus first. So that will be 7 minus 5. 7 minus 5. And 7 minus 5 is equal to 2. So it means the first term is 5 and the common difference is 2. Now the question here, we asked to get the 7th term. Now let's look at the 7th term. U7. So U7 now will be A plus 7 minus 1 times D. Yes. So here that should be equal to A plus 7 minus 1 is 6. 6 times d, we have 6d. So it means the seventh term will be our a, and we know the value of a is 5, plus, here we have 6 times d, and the value of our d is 2. So it means the seventh term will be equal to 5 plus 12, and 5 plus 12 is equal to 17. So it means the seventh term is equal to 17. Yes, that's the seventh term is equal to 17. Now let's look at it again. Let's look at the B rather. Our B, we have the 10th term. Now let's see U10. Now U10 will be A plus 10 minus 1 times D. So here we have A plus 10 minus 1 times the value of D. So that will give us A plus 9D. So that will be, the value of our A is 5. So here we have 5 plus 9 times D. And the value of D is 2. So it means here, what we have here will be, so what we have here now will be U10 will be equal to, we have 5 plus 18. And here we have 5 plus 18. And 5 plus 18 is equal to 23. So that's the value of U10. That's the 10th term. Now let's see the 12th term. That's C. So 12th term, U12, will just be equal to A plus 11D. Yes, that is A plus 12 minus 1 times D, which is the same thing as A plus 11D. So it therefore means that here, let's plug in the value of A and D. So the value of our A is 5. So we have 5 plus 11 times the value of our D is 2. So that will be 5 plus 22. Yes, because 11 times 2 is 22. So let's see 5 plus 22. So our U12 will be equal to 27. So that's the 12th term. Now the next question here is the sum of the first 10 terms. Yes, the sum of the first 10 terms. Now we're going to be using the two formulas. Yes, remember I said the first one, our Sn is n all over 2, 2a plus, this is a place, n minus 1 times d. And the second formula is n all over 2, we have a plus l. So these are the two formulas we're going to use to calculate for the sum of the first 10 terms. Now, let's look at it again. That's question D. Yes, question D. Now, sum of the first 10 terms, yes, 10 terms will be equal to, we have n all over 2, 2a plus n minus 1, yes, times d. Yes, let's call this Sn. So now, S10, the sum of the first 10 terms. Now, it means n now is 10. So here we have 10 over 2 in brackets 2a. Now the value of our a is 5. So it becomes 2 times 5 plus, then here we have n. And the value of n is 10. So we have 10 minus 1 times the common difference. The common difference is 2. So here we have 2. Now the whole of this. The whole of this. So it means here S10 will be equal to 10 divided by 2 is 5. So we have 5 in brackets. Now let's look at 10 times 2 times 5. 2 times 5 is 10 plus, here we have 10 minus 1, 9, then times 2 times 2. So it means here we have 5 in brackets, 10 plus 18. Yes, because 9 times 2 is equal to 18. So that will give us 5 times 10 plus 18 is 28. Yes, 10 plus 18 is 28. Now remember, we are still looking at the sum of the first 10 terms. Yes, sum of the first 10 terms. So it means in this case, our S10 will be equal to, now let's look at 28 times 5. 28 times 5. Yes, 5 times 8 is 40. 0, you carry 4. 5 times 2 is 10 plus 4. That will be 14. So here that will be 140. So it therefore implies that the sum of the first 10 terms is 140. Now, I want us to use the other formula. Yes, so alternatively, Alita, here, we said our Sn is equal to n all over 2 in bracket a plus L. And remember, we said L is the last term. Yes, so now we are looking for the sum of the first 10 terms. So it means the last term would be the 10th term. Yes, the last term will be the 10th term. So now let's figure out our L. Our L, which is U10, is A plus 9D. Yes, it's A plus 9D. So it means that will give us the value of our A is 5. And the value of our D is 2. So that will be 5 plus 9 times 2. And here we have it as 5 plus 18. 5 plus 18 is 23. So it means the last term, which is the same thing as U10, is equal to 23. Now, we are calling U10 the last term because U10 is the 10th term when considering the sum of the first 10 terms. Yes, the sum of the first 10 terms, the last term is the 10th term. So here, going by this formula, S10 will be equal to, we have n, which is 10. We have 10 all over 2 in brackets, the value of our A. Remember, A is 5, plus, now the last 10, that's L now, which is 23. So it means the whole of this now will be equal to 10 times 5 plus 23 is 28 all over 2. So that will give us 280 divided by 2, which is equal to 140. Yes, the same value with the value we actually got when we used this formula. So the sum of the first 10 terms is 140. So now we are going to look at the sum of the first 50 terms. Yes, the sum of the first 50 terms. The sum of the first 50 terms. Now, I want us to use this formula, the second formula. So here we have Sn is n over 2 in bracket A plus L. So now our L now will be equal to U50. Yes, U50. Why? Because we're actually looking at the sum of the first 50 terms. Yes, the sum of the first 50 terms. So the 50th term is the last term. So now U50 is A plus 49D. Yes, A plus 49D. And remember the value of our A is 5. So we have 5 plus 49 times the value of D, which is 2. So here that will give us 5 plus, we have 98. Yes, 49 times 2 is 98. So 5 plus 98 is 103. Yes, it's 103. So it means the last term, the 50th term, U50 is equal to 103. So now looking at the sum of the first 50 terms, here we have 50 all over 2 in bracket A, and the value of our A is 5. So we have 5 plus the last term, which is the 50th term, 103. Sorry, 103. It means the whole of this now will be equal to 50 in brackets 108 divided by 2. Yes, 108 divided by 2. So this is the same as saying 2 here is 1. 2 into 108 is 54. So now we are looking at 50 times 54. So let's look at 50 times 54. So 50 times 54, 50 times 54, 4 times 0 is 0, 4 times 5 is 20, 5 times 0 is 0, 5 times 5 is 25. So now we give us 0072. That's 2,700. So it means the sum of the first 50 terms is equal to 2,700. Yes, so that is the sum of the first 50 terms using this particular formula. Sn is equal to n all over 2 in bracket A plus L. So thank you so much. If you actually enjoyed this class, this section, please subscribe, share, and like for more of these classes. Thank you once more, and God bless you.